Hi everybody, welcome back to another video with Royalsoft Civil. In this video we are going to do an example from Conjugate Beam Method, and before I start I want to show you something. So if you're interested in structural analysis and you want to learn more about your class and the questions you do, you can go to my channel and playlist and click on structural analysis series and watch the videos for it. I have many videos in there. Okay, let's go talk about today's video. Okay, let me get my pen. Okay, so for this video, for the first problem of conjugate beam method, I'm going to do just a simple problem so you learn, and then next video I do a little bit harder question, and then one of the hardest question that you can see for conjugate beam method. Conjugate beam method, we don't really use it in structural analysis, but the students in the Hibbeler book, they went over it since they're using it in some parts. So I'm going to go over it because I know your teacher will test you on this problem. So example, and it's solve with uh, conjugate beam method. Conjugate beam method. Okay. And what is the question? And the question is find slope at B and max displacement. And we assume that E is 29 times 10 to the power of 3 KSI, and I is equal to 500 inch to the 4. And for this problem we have a beam which has a fixed end and a free end. We call this A, we call here B, and we call this C. At B we have a point load of 15 kips, 6 feet here, 6 feet here. So we're using English system. The first thing we need to do when doing conjugate beam method, we need to find the moment diagram and then convert the moment diagram to what? To conjugate beam. Okay, so the first thing we need to do is to draw the moment diagram. How to draw the moment diagram? So we see that this is 15, right? So this is fixed. Sum of forces in x is equal to 0. So ax is 0, so we only have an ay. Doing the shear force diagram graphically fast, very fast, Vx, we can see that it's like this. Right? And doing the moment diagram really quick, we can see that it's like this. and right here is 90. Okay, so this was what? SFD, and this is what? BMD. Now, we need to convert this to conjugate beam method. So in conjugate beam method, I'll tell you something you need to know. Need to know. Fix becomes free. Free becomes fixed. Internal roller becomes hinge, and hinge becomes internal roller. So you need to remember this. Fixed becomes free for support. For support. So fixed becomes free, free becomes fixed, internal roller becomes hinge, hinge becomes internal roller. And we need to convert this moment and put it on here. So right here we see we have a fix on the original problem, right? Fix and we have free. So this fix becomes free and this free becomes fixed. We don't have any roller or hinges, and so we don't have to do anything. So for conjugate beam, so we have a beam which is fixed right here. We don't draw any of the loading on this beam, but we draw this moment diagram, and we have this moment. The moment goes to right here, and then since this moment is below the graph, the loading right here goes downward, and you have to put this one 90 right here is what 90, and right here becomes 90 over EI. 90 over EI. Another way you can see this is I wrote, because I assume that downward is negative, but you can write negative 90 right here, and then when you see the negative, draw this downward. If this was positive on the other side, you draw it upward. And right here, however, when you're drawing this conjugate beam, you don't write negative, you just write 90 over EI. That's why I didn't write the negative at first, so you're not confused. And now we have to go to next step. So we have our conjugate beam method. I want to redraw the conjugate beam method. Oh, I'm not gonna redraw. So what they asked us, they asked us to find the slope at B and the max displacement. So we know that the slope is the shear at that point, and the max displacement is the moment at that point. And they said to find the max displacement. I forgot to say this. Okay, so let's go ahead find the slope first, and then I tell you something about the max displacement. So the slope at B, so right here was A, B, C, right? The slope at B is the shear at B, so we cut it. Okay, so I'm gonna redraw it right here. So cut like this. So V, right? And then it's right here. This comes down. This is 1/2 90 over EI times 6. Since right here was 6 feet. Okay. So now you just do sum of the forces in Y. So we do sum of the force in Y. So we do sum of the force in Y, upward positive, equals to 0. So negative VB prime. Since this is the conjugate beam, we call this VB and prime for uh, distinguishing it that it's conjugate beam. Negative VB prime minus 1/2 90 over EI times 6 equals to 0. So we know that theta B equals to VB prime equals to negative 270 over EI, and this is K feet squared, right? But they give us the E and the I value, so we just plug in the E and I value right here, and we get our final answer in radian, which is going to be 0.0026 radian. And what way? This way. So that's the answer. Always double check the calculation yourself with the calculator. Now, for the max displacement, think where the max displacement happened. So in this picture right here, we can clearly see that the max displacement happened at the fixed end or C. So, and what is displacement? Max displacement is the moment, which we get the answer in inches. So, to find the max displacement, we need to find the moment at C, MC prime. Why prime? Because again, it's a conjugating. So, sum of the moment C counterclockwise positive equals to 0. So, MC prime plus 1/2 90 over EI times 6, and I'm not going to rewrite this, I already did it right here. So 90 over 1/2 90 over EI times 6, right, and times 6 plus 2/3 of 6 equals to 0. Basic statics. So delta max, or this max displacement, equals to delta C equals to MC prime equals to negative 2700 over EI K feet cube. But we want the answer in inches, and how we can do that? They give us the E and the I value, and we just plug it in, and we get that delta max equals to 0.322 inches downward. There you go. So that's our final answer. Thank you so much for watching this video. If you have any question, please go ahead and comment below. Other than this, have a good day.